Economies of scale is a principle that is of fundamental importance to many industries. What this principle says, essentially, is that the more of something you produce, the less money, resources, and/or time each unit of that thing will cost you to generate. So if you design, develop, and produce 100 PlayStations, and each of those PlayStation consoles costs you $100 to manufacture, scaling up production to 1,000 of them might cost you overall more money in aggregate, because that's 10 times as many consoles, but the cost per console will likely go down, maybe to $90 a piece. So the profit you can make per console will tend to go up. Or you can lower your prices to compete with other products on the market without taking a financial hit. These savings are typically derived from reductions in materials cost, bulk purchasing the plastics, processors, hard drives, wires, and other components that you'll need to make the consoles, from reduced shipping costs per unit, from costs that you pay once and then apply as many times as you like. Designing the console, for instance, is an upfront cost that you can pay once and then apply an infinite number of times without increasing that upfront cost. And from other shared expenses that don't dramatically increase as the scope of your capacity increases, like the costs associated with your production machinery, managerial know-how, and the systems you have in place for getting the product from initial blueprint to someone's home. You might have some maintenance costs to keep using these elements, but you probably won't have to keep building new console-making machines after you've built the ones you need. There are typically also market-based benefits related to scale, including discounts from shippers, better prices from printers and component manufacturers, and more leverage in your negotiations with the stores that will carry your consoles. There are limits on this concept as well, as some types of product and industry don't scale in the same way, and there's a limit to the gains one might achieve from upsizing one's production capacity. It's unlikely you'll ever get the cost per console down to 50 cents, no matter how efficient your manufacturing setup and how many consoles you're producing, at least with today's technology. Nonetheless, the benefits of economies of scale are substantial enough that some industries would more or less collapse without them because of the nature of the product being produced, the market surrounding that product, and the costs associated with the construction of it, due to the components of which it is composed and/or the labor required to put it together. One industry that is thus reliant on this principle is the automobile industry. Before systems of automation, mass production and modularity were applied to this industry in the early 20th century, cars were so expensive that only the very wealthy could afford them. Part of the issue was that these cars were largely hand-built, and thus required a great deal of labor to manufacture, and the parts from which they were composed were also largely hand-built and produced in very small quantities. Scaling up the process through systemization, though, allowed one of the key innovators in this space, Henry Ford, to produce enough cars that he could save money on every single car part, which in turn allowed him to sell his cars cheaper, expanding the practical customer base for his product, which in turn allowed him to produce more cars, save more money on each car produced, and benefit from a virtuous declining cost cycle, which made his product ubiquitous and affordable even by the people who were building the cars. The degree to which automobile companies have been able to replicate this feat has varied, especially post-World War II, when a flurry of new automobile types hit the market, serving new audiences and thus further expanding the size of the product type's customer base, but also increasing the range and variety of components that are required and available. So you could produce and sell 1 million cars a year, but your savings per car might be lower than what Ford enjoyed back in the day, because you're producing a few dozen different models, most of which share only a few components between them. You'd still save on some components then, and you'd have economies of scale between your same model sedans, but you wouldn't benefit as much from the 1 million total cars because they have different parts, different manufacturing processes, perhaps different infrastructure required to make each different model. The economies of scale benefits are greatly diminished by this variety, even though there are other benefits to it. In recent years, though, some car companies have tried to account for this by introducing what are usually called modular design platforms, basically designing their vehicles of different types around some shared set of components so that their SUV is more likely to share its most expensive parts with their sedans and their pickup trucks. And thus, when it comes to those parts at least, they'll have economies of scale across most or all of their catalog, rather than just between vehicles of the exact same model. Two of the better-known examples of this modularization push are Volkswagen's MBQ platform and Volvo's Scalable Product Architecture, or SPA platform, the former of which was announced in 2012 and the latter in 2014. Both focus primarily on mid-range cars across a decent-sized spectrum, but they're also somewhat limited because of the constraints and requirements of internal combustion engine, or ICE-based vehicles. You can share things like gas pedals, some types of wheels and wheelbases, and in some cases the axles, and those shared components by themselves have no doubt saved both companies quite a bit of money and production time. Beyond that, though, modularization is somewhat limited because of how ICE-based vehicles are designed, powered, and manufactured. At the moment, the vehicle industry as a whole, worldwide more or less, is undergoing a transition to electric power from petroleum power. That changeover has a lot of implications, and one of them is that there are far fewer parts to worry about. And those parts are a lot more modular, transferable from one vehicle to another by their very nature. Car companies and companies that make components for car companies have realized this, and some of them are making huge investments to try to capture a share of this new facet of this industry that is expanding in some novel directions quite quickly. What I'd like to talk about today are modular electric car platforms and the impending skateboardification of the automobile industry. You're listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent, listener-supported show. If you're enjoying what I'm doing here, consider becoming a supporter. There are a variety of ways to do that, both monetary and non-monetary. You can find a list of those at letsknowthings.com/support. But one of the simplest ways is to become a patron at patreon.com/letsknowthings. Folks who contribute any amount each month via Patreon also receive, as a thank you, an additional episode of the show each month. A great big thanks to everybody who's already helping to support this show, and thanks in advance if you're considering doing so in the future. All right, let's get back to the show. The article I'd like to unspool today comes from Taiwan News, and it's entitled, "Taiwan's Foxconn and Yulon Aim to Supply 10% of World's Electric Cars." As I mentioned in the intro, economies of scale have long been vital to the automobile industry, and though manufacturers vary in their application of the various techniques that allow for such savings, most modern car platforms are developed with this attribute in mind. 90s and early 2000s era designs have been giving way to more versatile integrations and modular components, so that even vehicles that seem quite different from each other share a decent number of components. One of the more well-known implementations of this premise is found in Tesla, which is a US-based electric car company that, from the get-go, focused on building high-end, expensive, fancy electric sports cars and other vehicles, so that the components involved, the batteries, but also the other elements of these vehicle designs, would be well-funded and then would become cheaper over time due to economies of scale as they produce more of them. The goal was to generate these economies so that a $100,000 plus electric sports car would evolve into a $35,000 sedan, and the company has managed to get very close to that goal, due in large part to the sharing of components between vehicles, especially the massive battery packs that are the most expensive part of most electric cars today, which the company has focused on producing at larger and larger scales. They've also monetarily benefited from making adjustments to their manufacturing setup, like a recent change to some of their car chassis using a novel and giant casting machine. They've simplified the rear underbody of their Model Y vehicle so that 70 individual stamped steel and aluminum parts have been replaced by just 2 pieces of cast aluminum. This change, which Tesla founder and CEO Elon Musk called revolutionary during the Q1 earnings call for the company in 2020, could lead to a substantial savings for Tesla in producing that model, and even more substantial savings if they can then translate this manufacturing innovation to their other vehicles. Beyond the promise of economies of scale, then, another benefit of interoperable design architecture is that small tweaks in one corner of the production portfolio can eventually lead to huge upgrades and savings across the entire catalog, if those innovations can then be deployed more broadly. For all that Tesla is renowned for their innovations in this space and their embrace of vertical integration, which means in essence controlling as much of the supply chain as possible, which in this case means not just designing cars, but also manufacturing their own seats, their own batteries, their own chassis, which allows them to make adjustments and customizations that companies which have less vertical integration cannot make. For all the advantages they enjoy in the electric car space right now, Tesla is not at the forefront in terms of another innovation that many industry analysts see as the natural next step for modular, economies of scale focused electric car manufacturing and design. Tesla is bringing their designs and manufacturing in-house, sure, but they are not building their cars on skateboards, which, depending on how this space evolves, could put them in a tough spot within the next handful of years. A skateboard, in this context, is a car chassis that includes a completely self-contained vehicle propulsion system. In typical internal combustion engine-powered automobiles, engines are in one part of the car, steering components are separate from that, and there's a complex system of axles and brakes and suspension structures and gas lines and cooling systems, all of which connect various isolated systems to other isolated systems, linking tires to power source to the controls that humans use to tell these mechanisms what to do via buttons and levers and steering wheels. Electric cars simplify these systems substantially. Most ICE-powered cars have something like 30,000 parts, about 2,000 of which are moving parts, and therefore are the most likely to fail or need maintenance. Electric cars, because they don't have as many moving chemical combustion controlling components, only have about 20 moving parts, 2 orders of magnitude fewer points of failure, basically. And many of the most fundamental of these parts are related to the electric engine, the motor controller, and the battery. Many existing electric car designs are, by necessity, still quite similar to ICE-based car designs. This is partly out of tradition and the fact that many people would be naturally averse to anything that looks too deviant from what they think of as a car, not wanting to stand out on the road in a negative way, but it's also because much of our research and development over the past decades has been focused on ICE-based shapes, so we know how to build these sorts of structures for that type of engine and engine-supporting system design. Most car companies, too, are beholden to manufacturers of car seats, safety belts, windshield wipers, all of which make these parts in a particular way for a particular car archetype. And these car companies are not just set up to be able to easily segue away from these relationships to make their own custom-designed versions of the same. The switching costs from the typical car layout are substantial then, both on the market, but also in terms of design and manufacturing frictions. Those are the realities of the industry. The skateboard, I mentioned, is meant to be a base-level structure that frees these vehicle companies from a lot of those existing constraints and frictions. If you imagine a car chassis, the bottom part of the car, with 4 wheels and a flat or relatively flat surface connecting them. That's what we're talking about here. And the innovation is that this skateboard base contains all the vital systems of a typical vehicle. The power source, which in this case is the battery, the electric engine, and the motor controller. On top of that, the human-controlled portions of a typical car, like steering and brakes, are electrified, with the manual components replaced with computerized versions of the same. In practice, this means that the majority of the connections between the top portion of the vehicle, where the passengers sit, and this skateboard-like base that contains all of the car components of the car are electric and digital. You can connect a few wires and it's set up and ready to go. And in some cases it's even simpler, with wireless components connecting everything together into a sort of single car intranet. There are videos going around of these skateboards lacking any kind of top, with just a human being standing where the engine and the rest of the car would typically be situated, riding around on top of them like they're some kind of Segway or electric scooter. The implied promise is that with such a base, car companies can then pop whatever kind of top they want onto these fully functional, reliable, modular skateboard car systems. And that means the majority of the most expensive systems can be mass-produced, becoming cheaper and more reliable with time. And we might see economies of scale emerge not just between cars of a single model, and not even just between cars made by a single manufacturer, but potentially all the cars made by a great many manufacturers, because one company could make a reliable and inexpensive car base containing all of the important parts of a car, and then allow each company to put whatever they like on top of it, as long as they make use of the generic connection points that link the top passenger housing components with the bottom, everything else, move the car around components. This would be a fundamentally different way of producing vehicles, but it's a switchover that's already in the making, and the number and variety of participants in this evolution, even at this stage, is impressive. As of late October 2020, there are a slew of companies, some existing automobile companies and some smaller upstarts, that are focused on producing and promoting their own version of the car skateboard concept. General Motors, for instance, has what they're calling their BEV3 architecture and Ultium e-propulsion tech, which they insist are not skateboard designs, but which are similar in that they're modular and meant to be used broadly across their catalog of vehicles, allowing them to build atop a common structure. Though in this case, rather than having a single holistic, self-contained chassis, they have a series of components related to different e-car systems that can be broken apart or used together, which may help them achieve some economies of scale, but also build a wider variety of vehicles on different sized and shaped bases. A company called Canoe, with 2 O's, is working with Hyundai to create a skateboard base for smaller, city-focused passenger vehicles, alongside their own self-branded passenger fleets that would work something like Uber or Lyft, with a subscription service business model that allows customers to summon and use these tiny, smart car-like vehicles whenever they need one. All of the vehicles based on a smaller than currently typical skateboard car chassis. Rivian is partnering with Amazon to make skateboard-based electric delivery vans, and with Ford to make an electric Lincoln-branded crossover vehicle, alongside their own vehicles that are expected to hit the market in 2021. REE has a skateboard chassis design that's been licensed by Toyota's e-truck subsidiary, Hino, and they're focusing on a design that puts all the aforementioned vital electric vehicle components in the wheel arches, so in the space right around the wheels of the car, rather than throughout the base, which has allowed them to make it a nearly perfectly flat skateboard design that is shorter than their competitors, while most of the other companies I've mentioned have somewhat bumpier designs and taller designs, which would probably be somewhat more complicated to design for than a uniformly flat and shorter surface. Bollinger Motors is making their own skateboard-based vehicles, and they're focusing on heavier-duty vehicles like shuttles, semi-trucks, rescue vehicles, and pickups. Karma Automotive is making skateboards for other companies, while Volkswagen is making their own proprietary skateboard design that they'll likely also license out to other manufacturers. Looping back around to that initial article, though, one of the more interesting entrants in this space at the moment is Foxconn, a company best known, at least in the West, for manufacturing most of Apple's iPhones, and some of their other products as well, but which also produces a slew of products for other companies, mostly in the consumer tech space, but also on the industrial side of things. The article outlines Foxconn's plans in the electric vehicle skateboard space, which includes the introduction of their MIH Skateboard Platform, which is a modular, licensable chassis that they've been developing with a Taiwanese car manufacturer, Yulon Group, which itself is perhaps best known for building Nissan-branded cars, but which also makes its own brands, alongside vehicles for Luxgen, Tobii, Dongfeng, Fengshen, Chrysler, Geely, GM, Mercedes-Benz, and Mitsubishi. Foxconn and Yulon announced that they plan to introduce their own electric vehicle in 2 years, so likely sometime in 2022 or 2023, but that their intention is to have their MIH platform, which is a pre-packaged collection of hardware and software components that act as a sort of template for car makers, in 10% of the world's cars by 2025 or maybe 2027. Foxconn will also be producing their own car batteries beginning in 2024, which they say are an upgraded version of today's batteries, and that they've figured out a way to cut the weight of such batteries in half, which would be quite an achievement if this claim proves to be accurate. During the announcement of this undertaking, Foxconn representatives said that they wanted to become the, quote, Android system of the EV industry, end quote, referring to the de facto open operating system on most smartphones worldwide, which provides the base-level functionality for the majority of such phones and other devices of all shapes, sizes, and price ranges. This is potentially a significant moment for the electric vehicle industry, as no single company, be they a Tesla or a Foxconn, necessarily represents the next step of what we can expect, much less serving as any kind of leverage point for the industry as a whole. One benefit of automobile skateboardification is that the concept extends beyond just straight-up electric vehicles. The earliest models utilizing a proto-version of this concept, which were developed by General Motors back in the early 2000s, were actually based on hydrogen fuel cells rather than plug-in battery systems. But the concept still worked more or less the same way. The whole system fit into the chassis, and you could put a sedan, an SUV, or a pickup truck up top without having to make any fundamental changes to the skateboard base, which again allowed them to design around that base and reuse the same or very similar designs and manufacturing methods for the majority of their models, saving them tons of money, dramatically improving production efficiency, and opening up new possibilities in terms of what they put atop these modular bases. Or at least that's what was predicted to happen had they fully implemented this strategy across their product line. This is a model that also would seem to scale up and scale down quite easily, with many companies already developing semi-truck models. Those are the giant trucks that are used around the world, but which are especially important in the United States, because they carry those giant shipping containers from coastal hubs and airports to warehouses and stores around the country. Many companies have already developed big rig truck models of this same concept by basically just doubling or tripling the length of the skateboard, doing exactly the same thing as they would do with a sedan, but increasing the amount of battery and engine power and braking capabilities while maintaining the same modular benefits and economies of scale. The same parts, just a few more of them. These sorts of systems also allow for more consistent and iterative upgradability, both in terms of the software controlling the systems built into the base through over-the-air updates, just like with your smartphone and other devices, but also in terms of the hardware. The top portion of these vehicles can be popped off in 10 minutes or less, in most cases, meaning you could bring your car into the shop for a repair, they could pop the top part off your car and put it on a different, loaner skateboard base, and you could drive away in what is essentially your car for all intents and purposes, while they work on the battery or engine or wheel components back at the shop. That same principle also applies in terms of upgrading the top part of your car, or buying new engine components. You could, for instance, pop off the top cabin portion of your vehicle and replace it with a new one, without having to buy an entirely new engine, wheels, and other chassis-built components, which again are typically the most expensive parts of a vehicle. You can also do the reverse, buying a new, upgraded, perhaps more powerful or energy-efficient skateboard base, and put your existing car, the part where you sit and steer, on top of that new base, upgrading the innards of your car rather than simply replacing the whole thing, just because there's a more efficient base on the market or because your battery is depleted, which could result in less waste because you wouldn't be chucking the whole vehicle every time you want to swap out one component or try something new. This modular system could also make every vehicle on the road massively more versatile. If you're planning on making a trip out to IKEA or some other big box store, and you own a small sedan, which is not great for hauling a bunch of big purchases like furniture, you could stop at the car shop, swap out your sedan top for a pickup truck top for the day, and haul all your stuff back home, swapping your normal sedan top back in when you return the pickup top to the shop post-IKEA. This system enables potential futures in which our cars become more flexible, modular, upgradable, and efficient, alongside the existing electric vehicle benefits of producing far less pollution, especially as our energy generation technologies move more towards solar, hydro, and wind power, and away from coal and other fossil fuel-based production methods. It also makes other efficiencies in both production and ownership possible, which are often invisible to us consumers because we don't see the full extent of the production chain when we're buying and using our vehicles, but which adds a significant amount to the overall ecological cost of the vehicles we use, which is important even for electric vehicles because of how they're currently manufactured and the materials required to produce the batteries and other components. The next few years will likely be a transition period where most cars that hit the market will continue to be based on traditional manufacturing models, and most countries will still have more traditional ICE-based cars on the road than electric vehicles. From about 2025 onward, though, it's likely that the economic and ecological benefits of owning electric vehicles, especially those based on these skateboard chassis, will nudge those numbers in a new direction. If the promise of these things proves practical, at least, and if something even better and more groundbreaking doesn't come along in the meantime, which is always possible. Something to be watching between now and then is which companies opt to keep their designs proprietary and for their own use exclusively, which would be kind of an Apple approach to this new platform type, and which opt for the Android approach, aiming to be the system that the majority of vehicle companies use, which would give them perhaps less direct control over the market, but also perhaps vastly more reach and influence. If you're enjoying what I'm doing here on Let's Know Things, consider becoming a supporter of the show. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. Folks who contribute any amount each month via Patreon gain access to a call-to-action free version of the show and an additional episode of the show each month. But it's also super helpful to leave a quick review wherever you get your podcasts, to share the show with a friend who you think might enjoy it, and or to share your favorite episode on your social network of choice. A great big thanks to everybody who's already supporting the show in some way, shape, or form, and thanks in advance if you're considering doing so in the future. The book that I'd like to recommend today is called The Remarkable Life of the Skin, An Intimate Journey Across Our Largest Organ by Monty Lyman. I picked up this book for the same reason I pick up a lot of random science and history and other sorts of books, because I realized that this was a topic that I only knew a very superficial amount about, and I love it when authors who are experts in particular fields go into great depth about that subject, so that I can go beyond the superficiality of my current knowledge of that topic. The skin is indeed utterly fascinating, as most things tend to be once you get into them with sufficient depth, and the author does a very good job of making the case that knowing more about the skin, but also perhaps treating the skin somewhat differently than we typically do, might be prudent for most of us because of the fact that it is the barrier in a very real way between the ecological system that we refer to as ourselves, our bodies, and the rest of the world. Now, if any of that sounds interesting to you, if you're keen to learn a bit more about the skin in a very broad way, consider picking up a copy of The Remarkable Life of the Skin by Monty Lyman. You can find out more about me and my work at colin.io. You can find the show notes and transcript for this episode and every episode of the podcast at letsknowthings.com. You can find my other podcast, Brain Lenses, wherever you get your podcasts or at brainlenses.com, and you can find my blog at exilelifestyle.com. Feel free to reach out and say howdy on your social network of choice. I am Colin Wright on Facebook and at Colin is my name on Twitter and Instagram. Thank you so very much for listening. I'm Colin Wright, and I'll talk to you again next week.